I will subtract 7 from both sides. I have negative 5x is greater than or equal to 6. Then I divide by negative 5. X is less than or equal to negative 6/5. Please note, this is something that you learned back in algebra. When I divide by a negative, or when I multiply by a negative number, I must flip the inequality sign. And we will go over that a little bit later on when we get to an activity dealing with absolute value inequalities. But when we divide or multiply by a negative number, we must flip the inequality sign. So that's why we flip the inequality sign. So x is less than or equal to negative 6/5. So since it's less than or equal to, I will fill this in with a filled in circle. And it's less than or equal to negative 6/5. So I take negative 6/5 and I go to the left forever. This is the same thing as saying 3 is less than or equal to 2x minus 5, and 2x minus 5 is less than 8. So I can solve those separately if I wanted to. I'm going to keep them all the same, all lined up, and keep it as one giant inequality. That makes it easier. So I'm going to, at least it makes it easier for me. So I'm going to add 5 to everything. So if I add 5 to the 3, that becomes 8. And if I add 5 to the 8, that becomes 13. And then I'm going to divide everything by 2. So 8 divided by 2 is 4, less than or equal to x, which is less than 13 halves. Now 13 halves, note, is the same thing as 6.5. So if I were putting this on a number line, x must be between 4 and 6.5, or 13 halves. Notice that the 6.5 is an open circle. However, this problem is restricted to the integers, so I'm not actually putting that graph on my final answer. It must be greater than 4, and then here is 13 halves, and it must be strictly less than 13 halves. The next integer that's close to that is 6, so we would stop at 6 if we were drawing it with a line. However, we can't actually draw this with a filled-in line because that would include all of the non-integers in between 4 and 6. So we can only fill in the integers with dots, or filled in circle values. And so that means my final answer is just 4, 5, and 6. So I would just graph 4, 5, and 6. Okay, so the solution set in problem 1 was x is less than or equal to negative 6/5. And the solution set in the second one is x is equal to 4, 5, or 6, which we could also write as a set with the curly brackets if we wanted to, 4, 5, 6.